All right, boys and girls. So we're going to talk on this video. We're going to talk about what are called two-digit divisors. Um, that's when you are taking something outside of your house, and it is a two-digit number. And so this is going to be. I always tell my kids this is really kind of the new part when it comes to fifth grade and division. Most of the time in fourth grade, you're going to stick to what's called a one-digit divisor. So really, kind of just your basic facts. There could be some teachers in fourth grade that maybe, divide by friendly numbers or like multiples of 10. So maybe divide by 10 or 20 or 30 or something like that, which we still do in fifth grade. But a lot of times when it comes to division, it could just be just a two-digit number. It could be anything from like this one that's in the teens to I've seen one go all the way up on a test before, and it was like in the 70s. It was like divided by 72 or something like that. So I think that sometimes will, kind of make it seem like it's going to be a harder problem when the reality is if you know how to divide, if you know the steps for division, the division's not going to change. It might look harder, but the steps stay the same. A lot of times in my class, I tell my students the math doesn't change, the numbers change. So you're looking at it and you're thinking, okay, well, does McDonald's sell cheeseburgers? That's still going to apply to a problem like this, even though we're dealing with a two-digit divisor. And so let's look at this problem. This problem is 358 divided by 15. And so I think one of the things that kids kind of freak out about is when they look at these two-digit divisors, they go back to facts and they go, well, I don't know my facts of 15. Well, that's true. Most students don't. You might know some. I always catch kids that will know some of them, but you're not really, it's not required of you to know those facts. If this was 358 divided by 8, it would be much easier because you should know your eights. 358 divided by 15 is going to be more work because we don't know our 15s. Well, there's some ways around that, and there's some strategies to really think about when you divide by two-digit numbers. The first would be, think about what number it is, 15. Okay, well, I don't know my 15s, but I do know some of my 15s. It's kind of like if I were to start writing them out, I know 15 times 1 is 15. And I know double 15, 15 times 2 is 30. And 15 is kind of a friendly number. So, if you have good number sense, you might think, well, hey, this is just maybe skip counting by 15, or maybe it's skip counting by 10 and then a 5. So like on my next one, I'd go up 10 to 40 and then add 5 more. That gives me 45. And then look, out to the side, I already have several 15s written out. That might be very beneficial for me. I might just need to write a few. Sometimes I'll tell my students to do that. Hey, just write the first 3 facts. Just get the first 3 out, and then from there, go back to, just go divide and see what happens. Maybe those facts are the only ones you need. Maybe you need to go and explore and get some more. But at this point, I've got a good start. And so I'm going to look at this and I'm going to think 358 divided by 15. All right, so let's start looking at this problem, 358 divided by 15. So I'm going to first think, how many times can 15 go into 3? I'm going to go to the first digit. Well, here's the thing. In my class, I teach my students that it cannot go in simply because 15 is bigger than 3. The reality is it can go in, it just would go in 0 times. But I teach my students to skip that step. It's more work, and it might potentially confuse you. And so the first thing I always teach my students about division, especially when they're going step by step, is, again, you're trying to get close without going over. Well, you're kind of already over it because 15 is bigger than 3. So the first division problem I would look at is really 35 divided by 15. Or, thinking multiplication, how many times will 15 go into 35? Well, looking at the right side of my screen here, I can tell that it can go in twice. Because again, my goal is get close or get exact, but I can't go over. So if I look at 15 times 2, that's going to take it in, twice basically. 15 times 2 is 15 doubled, but if I take it times 2, that gets me to 30, and that's pretty close to 35. And so I'm going to take the same strategies as before. When we did one-digit divisors, I'm going to follow does McDonald's sell cheeseburgers? And I'm going to think about, at this point, I'm going to subtract. So 35 minus 30 is only 5. I'm still going to compare. My question in my mind is 5 less than 15 my divisor? It is, so I'm good. And then I'm going to now bring down. And so now I have the problem of 58 divided by 15. And again, I just like making a new little house there to show that I'm back at the top of my steps. I'm going back to division at this point. Okay, so now I'm at 58 divided by 15. So I can stop and I can think about my 15s again. So I got all the way to 45. That's actually pretty close to 58. What I could do is I could try one more and just see what happens. So I'm going to go back over to my 15s on the right, and I'm going to do the same strategy of I'm going to add 10 and then add an extra 5. And so if I add 10, that takes me to 55, plus another 5 takes me to 60. And so if I'm looking here, now I have 4 facts listed out, and the last fact takes me to 60. So that's 15 times 4 takes me to 60. That's too far. That's more than where I want to go. And so I'm going to back up 1 to 3. I'm going to say it can go in 3 times. And 15 times 3 is 45. And again, I'm going through my steps. I'm now going to subtract. 8 take away 5 is 3. 5 take away 4 is 1. And I'm looking at the answer of 13. Now, at this point in my problem, I'm going, okay, well, I don't have anything else to bring down. There's no other digit out here. It's just 358. And so this would turn into, again, what's called a remainder, or this is left over. And so I'm going to put that our quotient here is 23 with the remainder of 13. And so even though it's a 2-digit number as a divisor, I'm dividing by 15, my work pretty much is the same as a 1-digit divisor. I have, maybe had to put more effort into it. Maybe I couldn't do as much mental math. I had to show some work out to the side, but still the steps are the same. You're still dividing. You're still using your same division steps that you learned as a 4th grader. So this would be known as a 3 by 2. This next problem is what I would call a 4 by 2. This is the biggest that you would see in 5th grade. And when I say biggest, I don't mean the digits are the biggest. I'm saying you will see what are called 4 by 2s. You will have a 4-digit dividend and a 2-digit divisor. And so this looks really scary. And this is kind of that first time, like I was saying in another video, where this might be the first official, this looks really difficult, I can't do this moment for a lot of students. But it's really not too bad. It's one of those things, it takes a lot of practice. And so this problem is 5,437 divided by 23. So in my mind, I'm thinking, all right, 23 times something is either going to give me 5,437, or I can get close without going over. That's my goal here. All right, so kind of like on the previous problem, I don't know my 23s. And so this time, instead of writing out some 23s, I'm going to take a different approach. I'm going to use you can either think of this as compatible numbers, or you could think of it as just maybe using some good number sense, or maybe even some estimation. And so what I'm going to think of out to the side is, if I have a divisor of 23, I know that's very close to 20. And I can skip count by 20s pretty easily and I feel like most 5th graders should be able to, because skip counting by 20s is just like skip counting by 2s, but you just add a 0 to it. And so I'm thinking, instead of writing out a bunch of 23s, let me just think about how many 20s maybe can go into some of these numbers. Okay, so let's try that and let's see what happens. So my first step would be, how many times can 23 go into 5? Well, it can't. 23 is bigger than 5. So again, we're going to skip that and we're going to move over to 54. So how many times does 23 go into 54? And again, you're thinking, all right, I don't know my facts of 23, but I know my facts of 20 or my 2s, because it's really the same thing. And so what I'm trying to make you guys understand is, sometimes when you have these bigger dividends, or excuse me, when you have these bigger divisors like 23, don't overthink it too much. You know, sometimes kids can do too much work here. And so I would want a kid to think smarter, not harder. So instead of sitting there writing out all of our 23s, let's just think about 20s. Well, two 20s, 20 plus 20 gives me 40. Three 20s, 20 plus 20 plus 20, or 20 times 3 is 60. So if I'm thinking about 23, I'm probably going to think to myself, well, 23 times 3 is probably going to be too much. It's going to go past 54. So out to the side, and I always tell my kids, it's going to look like this. You're going to, you know, if you have a big, long division problem, your paper should have some scratch work somewhere. I mean, there should be some work out to the side. So I'm going to take 23 and I'm going to just times it by 2 to see what I get. I don't think I'm going to go past 54. I think I'm going to be close to 54, but not go over it. So notice what I set up there. I'm not trying to do it in my head. I'm going to set it up as a 2 by 1 and I'm just going to go solve. 3 times 2 is 6. 2 times 2 is 4. That should be a quick and easy problem. Okay, so I got 46. Here's the thing. At this point, I know if I try 23 times 3, I'm going to go over 54. So I'm just going to go back to my problem and I'm going to start solving. I'm going to say it goes in twice, and that's going to give me 46. And at this point, I'm going to still use my same division steps and go through this problem. Okay, I got to subtract here. There's, you know, you can go and you can regroup, you can count up, however you want to do this. Sometimes, you know, I've got a lot of students that subtraction is still a huge issue for them. And so maybe this could be the toughest part for just, you know, maybe some students. I don't know. I've seen that where kids, the division's really good and then they goof on their subtraction. You just got to go slow. So at this point, I would have to regroup here. I'd have to go borrow. I'd have to turn the 4 into a 14. And 14 take away 6 is going to be 8. And then I'd have to borrow 1. So 4 minus 4 would be nothing. So I'd have the answer of 8. Well, I still would want to slow down and think, okay, I'm going to compare here. Is 8 less than 23? It is. So I'm still good. And I'm going to now bring down and I'm going to start over. And so now I have 83 divided by 23. Okay, so at this point, I already have one fact out to the side. 23 times 2 is going to give me 46. And so there's a couple of ways I would approach this next step. 83 divided by 23, I would probably stop and go, okay, well, if I'm counting by 20s, 20, 40, 60, 80. 20 times 4 is 80. But if I did 23 times 4, that's probably going to take me over 83. So I'm really going to probably just think, well, you know what? I probably just need to go to the next fact of 23, which is just 23 times 3. So I'm going to set it up again. I'm just going to set up a 2 by 1. I'm going to just show some work here. 3 times 3 is 9. 3 times 2 is 6. Okay, it's 69. And so I could do 23 times 4 and see if that's okay. And see if, well, hey, yes, it truly does go over 83. Or I could just say, you know what, I think this is going to work. And I could go set it up and subtract. And this is going to be where I always tell my students, this is why the compare part is so important. So if I subtract this and I get something bigger than 23, then I know I made a mistake. If I get something less than 23, then I'm okay. And so that's why the compare part is so big. When you are, going through those steps before you bring down the next digit, you need to compare. All right, so I'm going to subtract here. I'm going to have to regroup again. So this is going to be 13. Take away 9. That's going to give me 4. This is going to turn into a 7. 7 minus 6 is 1. I'm good here. And the reason why I'm good is because 14 is still less than 23. All right, at this point, I'm looking at it. I'm going, okay, still have more. And this is kind of this is where it gets its name. It's long division. I always tell my students, that's why it takes a while to get the answer. You got to keep bringing it down, and you have to keep dividing until you are done. So at this point, I'm going to keep going. My next step is 147 divided by 23. Whew. All right, well, let's see what happens here. My last 23 I wrote was 23 times 3, and it only got me to 69. So I'm thinking at this point, probably need to go a little bit higher than this. And so I'm going to go back to my 20. So I'm going to skip count by 20. So that's 20, 40, 60, 80, 100, 120, 140. That takes me to 7. 20 times 7 is 140. But it's not 20, though. It's 23 is what we're dealing with. So I'm going to back it up one. I'm going to go to times 6, and I'm going to just try it. And I want to see what happens here. And I always tell kids, I'm being honest with you when I'm making this video. I don't know. I don't know my 23s. I mean, I have a pretty good idea what it's going to be or what is it going to be close to, but I don't know my facts of 23. I'll have to go and solve it. So I'm going to solve 23 times 6. 6 times 3 is 18. 6 times 2 is 12, plus 1 is going to be 3. All right, so let's think about what we have here. We've got 23 times 6. That gives me 138. That's pretty close to 147. And, if I was doing this in class, I'd kind of pause and I'd tell my students, okay, let's think here. If we went and did another fact of 23, if we did 23 times 7, would we go past 147? And of course, everybody would agree there because there's just no way. So I could stop here and say, okay, this is as close as I can get. Remember, you want to get close, you don't want to go over. So this is as close as I can get. 23 times 6 is 138. So I'm going to have probably a remainder here. I'm going to have some leftovers. But that's going to happen in division. Not every time are you going to divide and something go in equally. And so especially when you have two-digit divisors. A lot of times with two-digit divisors, you're almost going to be guaranteed. And I say it like that. I mean, there's a really good chance you're going to have a remainder. And so 147, take away 138. I'm going to look at this again. I'm going to have to regroup here. I'm going to have to borrow. This is going to turn into 17 minus 8. That gives me 9. This would be 3 here. So I can just subtract out and I'd have zeros. So my final answer here would be 236 with a remainder of 9. And so it took me a while to get that. But you know what? If you look out here to the side, here's what I like telling my students. You don't want to just overwork yourself. Like, I wouldn't want a kid to sit there and go, okay, oh man, I don't know my 23s. So I just need to write them all out. Let me write 23 times 1, 23 times 2, 23 times 3. No. You don't have to do that. You want to think smarter, not harder. And so what I did was I really thought about my 20s instead. And that helped me determine which facts I needed. And think about our answer. Our answer is 236 with a remainder of 9. Look at our facts out to the side. You'll see the 2, you'll see the 3, you'll see the 6. And again, that takes a lot of practice, but if you practice it, you'll get it, and it'll make sense to you. It's those that don't want to put in the practice that are going to be hurting. Okay, this last problem here, I'm going to go a little bit faster. I'm not going to talk as much, but the steps are going to be there. So watch me work this one. Okay, so this is 7,258 divided by 49. 49 is really, really close to 50. And I know my 50s. That's like 50 cents. I can count up by those. Okay, so first step, can 49 go into 7? No, it cannot. 49 is bigger than 7. Can 49 go into 72? Absolutely. And I'm going to think about now counting by 50s. I'm not really going to think about 49s until I absolutely have to. So I'm going to say 49 can go into 72 only once, because 50 can go only once. If you double 50, you're going to get 100. If you double 49, you're going to get really close to 100. And so at this point, my first step is pretty easy. Even though it's a scary looking 2-digit divisor, man, that's pretty easy. And so I'm going to subtract this out. I'm going to have to regroup here. I'm going to have to borrow 12, take away 9 is going to be 3. I'm going to have to borrow 1 here to make that a 6. Subtract here, I'd get 23. Okay, I'm good. I've subtracted. I compared. 23 is less than 49. Now, this is something that could happen when you are dividing by 2-digit divisors. You could be looking at, some larger numbers here. You just have to go slow and really think about it. And so I'm going to go to my 50s again, and I'm going to think to myself, okay, if I was counting by 50s, 50, 100, 150, 200, 250, well, 50 times 5 is 250. I think 49 times 5 is going to give me more than that. Or it's going to be too big, in other words. I don't think that that's going to be a good fact for me to practice. But I think 49 maybe times 4 might be something I might want to look into. And so I'm going to try that out to the side. 49 times 4, 9 times 4 is 36. 4 times 4 is 16. 16 plus 3 is going to be 19. So I've got 196. It's kind of like this. If I added another 49 to 196, I think I'd go past 235. Maybe not by a lot, but I'd go past it. And so I'm going to say this is only going to go in 4 times. And so I'm going to write 196 underneath, and I'm going to go subtract. So I can't take 6 from 5. I'm going to have to regroup. This turns into 15. 15 minus 6 is going to give me 9. I'm going to have to borrow 1 here. When I borrow, that turns into a 2. I can't take 9 from 2, so I'm going to have to borrow again. That turns into a 1. 1 gets tacked on. 12 take away 9 is a 3. So I've got 39 here, which I'm good. That's less than 49. And so I'm going to bring down this last digit, and my last problem is going to be 398 divided by 49. All right, and then again, I go back to, what I've already done, and I want to think about, okay, let's see here. I'm counting by 50s. I'm not counting by 49, so let's see if we can get up close to 398. So I've got 50, 100, 150, 200, 250, 300, 350, and then, of course, I get to 400. So that would be times 8. 50 times 8 is 400. And that's all I'm doing is I'm just counting up on my fingers. I'm counting up in my mind here. So I think that's probably going to be too much. We'll see. I'm going to go back a fact here. Instead of 8, I'm going to go 7. And I'm going to say, all right, let me go try 49 times 7. Let me see what this gets me. And then I'm going to kind of just look at it and see if maybe we need to adjust. All right, I've got to know my facts here. Again, I've got to know my facts to be able to divide. 9 times 7 is 63. 7 times 4 is 28. 28 plus 6 is going to give me 34. And then here's my debate. All right, it's going to be really close. If I added another 49 to 343, would I go past 398? Would I be really close to it? Is it one I maybe want to go try just to see? Just for comfort, I would probably try it. And I don't know what's going to happen here, but I know it's going to be close. I do know if it goes over, then I'm going to stop and go, okay, well, it can only go in 7 times. So I'm going to do 9 times 8, which is going to give me 72. 8 times 4 is 32. 32 plus 7, if I go slow here, 32 plus 7 gives me 39. And then now I'm like, ooh, hold on. I'm glad I checked it. Because if I do this now, 49 times 8, that gets me really close to where I need to be. It takes me to 392. So I'm going to say it does go in 8 times. And I'm going to subtract one more time, and I'm going to have a remainder of 6 here. But that last step, I really got, is one of those things where, hey, I just went and tried one more fact just to double check myself, and it was good that I did because it ended up being the right answer. And so, again, when you're working these problems, you've got to stop and think, hey, what do I need to do to be successful? And a lot of times it's showing your work. It's not trying to do mental math. We were counting by 50s on that problem. That was the mental part, but I don't know my 49s, so I had to go and write my 49s out to the side. I only had to do 3 of them. I didn't sit there and write out all of them. So you have to do those things in order to get these questions right. You have to. I always tell my kids, you got to go to work. That's part of it's like having a job. You got to go to work. And if you want to be successful, you've got to do it. So hopefully this video is going to help. You would, to me, if division's hard for you, you might want to watch these several times. And that way you can really get down the steps, get out a piece of scratch paper and work these problems with me. This is, how you're going to learn. And that's practice. Practice makes perfect.